now. So we talked about different quadratic equations, right? Quadratic equations can be solved in three different ways. So the form ax squared plus bx plus c is equal to 0 when a is not equal to 0, right? We solved it by factoring. We did that in chapter 6, right? And then the second way was we did it by completing the square, which we learned on Friday. And today we will learn how to solve every single quadratic equation using the quadratic formula. Now, the cool thing about the formula is it works for every quadratic equation, okay? It works for every quadratic equation. Because when we did it by factoring, it didn't work. It only worked for quadratic equations that can be factored, right? But this one, it works for every single one. So I'm going to go through how this formula was created. It's actually derived from by completing the square. So when we had ax squared plus bx plus c is equal to 0 and a is not equal to 0, this is our quadratic equation, right? So as you can see, deriving the formula, I'm going to derive it right now, but it's very long process over here, so I'll show you what to do. You don't have to memorize this, okay? Back when I did it, they actually quizzed us on it. But first, we move the constant term to the right-hand side, right? So that's our c. So ax, oh, that's not what I was trying to do. So we have ax squared plus bx is equal to, so we're going to subtract c on both sides. And because a, we don't know what a is, right? A is some number that's probably going to, it could be any number, right? We have to divide that because we want our x squared coefficient to be 1. So when we divide both sides by a, we then have x squared plus b over a times our x is equal to negative c over a. And what do we do next? Whatever our coefficient for x is, we take that, in this case b over a, and we multiply by half. And we get b over 2a. This b over 2a then is squared, so we get b squared over 4a squared. So you notice this is what we add to both sides, right? Does that sound familiar, all these steps? But it looks a lot more complicated because we have this b and b over a and all this other stuff. So we add b squared over 4a squared to both sides. So this is, I'm going to put it to the left of minus ca, okay? So we got b squared over 4a squared and then minus c over a. Right? Does that look clear? And when we factor the left-hand side, don't forget this b over 2a is the factor. So this becomes x plus b over 2a quantity squared is equal to b squared. I'm going to combine this as one fraction. So what's the LCD of 4a squared and a? So this c over a needs to be multiplied by 4a over 4a so that we can get 4a squared. So you see this is equal to 4ac over 4a squared. Right? So this is b squared minus 4ac. All of this is over 4a squared. Now we square root both sides, and we get x plus b over 2a, right? These squares cancel out, square and root. And on the numerator, we get the radical b squared minus 4ac, and we could separate it, right? The denominator, square root of 4a squared is what? It's just 2a. And then lastly, we subtract b minus 2a. So negative b over 2a plus or minus square root of b squared minus 4ac over 2a. And you see how the denominator is both 2a? So we can write it as negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. And this is our quadratic formula that we derived from the quadratic equation. So none of this is going to be tested, right? Because you've been doing all of this by completing the square, right? This is completing the square without any of the numbers. So as long as you memorize the formula, you'll be good, right? So this is our quadratic formula. So please try your best to memorize it. Negative b plus or minus the square root of b squared minus 4ac, and then the entire side is divided by 2a. Okay. Now we will try some problems where we use the quadratic formula to solve quadratic equations. So as a reminder, I will write the quadratic formula up here on the right. X is equal to negative b plus or minus the square root of b squared minus 4ac, and then the entire side over 2a. Okay, so when you look at a quadratic equation, please remember it has to be written as ax squared plus bx plus c is equal to 0. If this is not set equal to 0, you need to first set it equal to 0. Okay, so now I can identify in this first problem 6x squared minus 7x minus 3 equals 0. A is equal to 6. B is equal to negative 7. Remember, the signs, the operations are part of the coefficient, right? And then the C is equal to negative 3. So if you don't use the correct signs, you will get the wrong answer. So let's plug it into this quadratic formula. So negative b is the first problem, right? So I have to write negative 7 because b is equal to negative 7. Plus or minus, and then the square root of b has to be squared minus 4 times a times c. And then all of this is over 2 times a. So this is what x is equal to. Right? When we solve for x in a quadratic equation, if you recall, when we factor, we set every factor equal to 0 and solve for x. Those were our, x-intercepts, right? Or in function notation, 0 of the function. All right, so let's solve this. We're going to simplify this a bit, right? So negative 7 is positive 7. Then we have plus or minus the square root of. So I would probably, if you don't want to do this by hand, throw this into the calculator, but make sure you use parentheses for that negative, right? So negative 7 quantity squared is 49. And then you have 4 times 6 times 3, so that's 72, right? Positive 72. And then over 12. So 49 plus 72, that's what, 121. So this is 7 plus or minus radical 121 over 12. And radical 121, I asked you to memorize, is equal to 11. So you have 7 plus or minus 11 over 12. Now those are integers, right? So you do have to do them separately. You got 7 plus 11 over 12 or 7 minus 11 over 12. So the first one, we get 18 over 12. And when you do any fraction that can be simplified, you should reduce it, right? So this is 3 over 2. And for 4, this is negative 4 over 12. So you get negative 1/3. So at the very end, you should write it as two solutions. X is equal to 3/2 or x is equal to negative 1/3. Okay, we don't do set braces a set too often here, so you don't have to write it this way. This is perfectly fine. Okay, that was our first problem with quadratic formula. So if that made sense to you, I would like for you to try this next one. I'll leave it up on the left-hand side so you could refer back to it, but try this next one. Make sure it's set equal to 0 first. Identify your A, B, and C, and then plug into the quadratic formula. Let's try the second problem. Let me move in a bit. So we have A is equal to 3, B is equal to positive 2, and C is equal to negative 8. Right? As long as you identify these properly, you should be good. X is equal to negative B plus or minus the square root of B squared minus 4 times A times C. All of this is over 2 times A. So you notice the 2, I didn't need to write parentheses around it because it's a positive number. Alright, so what do we have? We have negative 2 plus or minus. This is 2 squared is 4. 4 times 3 is 12 times 8 is 9. No, 1. Oh, whoops. 12 times 8 is 96. So let me write this as plus 96 over 6. And 4 plus 96 is 100, right? Negative 2 plus or minus radical 100 over 6. And radical 100 is equal to 10. So we have two solutions here. We have x is equal to negative 2 plus 10 over 6, or x is equal to negative 2 minus 10 over 6. So we need to figure out what these numbers are. Negative 2 plus 10 is 8 over 6, which is equal to 4 over 3. And negative 2 minus 10 is negative 12 over 6 is equal to negative 2. So did you get those two solutions? X equals 4/3 or x equals negative 2. Any questions there? Okay. How many people got that right? Did you forget about the... Okay, but is it because you didn't do plus or minus? That plus or minus means there are two of them. One is with the plus and the other is with the minus. So let's do the next one and then we'll see how the plus or minus affects the two answers. Okay, so in this next problem, we have 9x squared is equal to 12x minus 4. So we have to write it in standard form. 9 is, you see that the coefficient for x squared is positive. So I'm going to bring the other two terms to the left-hand side. Right? If it were negative 9x squared, then I would move the negative 9x squared to the right-hand side. So in this case, I get 9x squared, and then I'm subtracting 12x, adding 4 is equal to 0. That way I get A is equal to 9, B is equal to negative 12, and C is equal to 4. So I can plug this into the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4a and c over 2 times a. Okay, so let's continue this. Negative 12 is positive 12. Plus or minus, this is the square root of 144, right? And then we have, what is this, 436 is still 1, okay, so this is minus 144 over 18. So 144 minus 144 is 0. Square root of 0 is 0, right? So do you see how 12 plus or minus 0 means there's no we don't have two different answers because 12 plus 0 and 12 minus 0, they're the same answer. So in the very end, we get x is equal to 12 over 18. We should probably divide this by 6 to both, so we get 2 over 3. So x is equal to 2 over 3. It has one unique solution, but what that really means is it's a double root. This is called a double root or a repeated root. Double root or repeated root. And if you recall, do you remember when we factored a perfect square trinomial? We get a binomial squared, right? So, oh yeah, they show it down here actually. So this factors 9x squared minus 12x plus 4 equals 0 was actually a factorable problem. If you factor it, you get 3x minus 2 quantity squared is equal to 0. This is a perfect square trinomial. So in the end, what do we have? We have 3x minus 2 equals 0, and 3x minus 2 is equal to 0. Right? And if you solve for x, you add 2 and divide by 3. Same for the right-hand side, right? That's the second one. So you see how both answers are x equals 2/3. So that's what a repeated root is. Also, when we talk about graphs in the next section, you'll see what a repeated root will look like. All right, so that was the quadratic formula. Do you want to try this next problem? I guess I'll leave this up here on the left. So I'll give you a few minutes to work on this one. Well, let's take a look at the next one now. So we first had to set this equal to 0. That means I'm going to add 1 to both sides. So we have 4x squared minus 4x is plus 1 is equal to 0. So a is equal to 4, b is equal to negative 4, and c is equal to 1. Now I can plug this into the quadratic formula. I have negative b plus or minus the square root of b squared minus 4ac over 2a. Does that look good to you? Now on the left hand side, on the left over here, this is positive 4. So I'm just going to continue to the right, save some space. So I got 4 plus or minus radical 4 squared is 16 minus 16 over 8. 16 minus 16 is 0, right? So we have 4 over 8 is equal to 1/2. We have a repeated root of x equals 1/2. Did everyone get that? Alright, let's move on then. So here's an example of a quadratic equation where the answer will be in radical form. Alright, so first we set this equal to 0 to get, we have to subtract 5 to both sides, so we get x squared minus 3x minus 5, right? That means a is equal to 1, b is equal to negative 3, and c is equal to negative 5. So this is our negative b plus or minus b squared minus 4ac, right? And then this is our 2a. Now, under the radical, we have negative 3 squared is 9, and then negative 4 times 1 times negative 5 is positive 20. So this is the radical we get, right? Radical 29. So you notice, because radical 29 cannot be simplified, you would leave it as 3 plus or minus radical 29, all of this over 2. So if the radical if you were able to simplify it, please do, because you will get examples where if the radical were simplified, some of the answers would kind of reduce further with the denominator. So kind of keep that in mind there. Let's try this next one together. We have to first set this equal to 0. The 2x squared is positive, right? So I'm going to move these, the x plus 7 to the left-hand side. So I have 2x squared minus x minus 7 is equal to 0. That means a is equal to 2, b is equal to -1, c is equal to -7. And you won't need to write these out, the ABCs out. I'm just doing that for the time being so that you know how to plug it in. But once you get comfortable, you can just completely skip that step. So you get x is equal to -b. And even this, later on, you'll just probably write +1 there. Plus or minus the square root of b squared minus 4ac over 2a. So as I was saying, this is +1 plus or minus the square root of, this is 1 plus, right, because negative times negative positive, and this is our 56 over 4. Okay, makes sense. We can add that. We get 1 plus or minus radical 57 over 4. And radical 57 you can't simplify. So that would be it. All right. We're going to look at an example where we will simplify at the very last step. Okay. So this one I want you to watch carefully. As you can see here, your a is equal to 3, b is equal to -6, c is 2. Right, so as we plug it into the quadratic formula, you get -b plus or minus the square root of b squared minus 4ac over 2a. Right, so b squared is our 36 and minus, what is this? This is 24. So the square root of 36 minus 24 gives us radical 12, which then simplifies to 2 root 3, right? Because you get radical 4 times radical 3 is equal to 2 radical 3. So as you can see here, this is written as 6 plus or minus 2 radical 3 over 6. Vivian, your microphone is on. Okay, you see now, once you simplify the radical 12, this 2, right? You can see that the numerator, there's a common factor of a 2. So I'm going to factor that out from both terms. So 6 divided by 2 is 3, plus or minus 2 root 3 divided by 2 is radical 3. See that? If you did distributive property, you will get 6 plus or minus 2 radical 3 over 6. And we have a common factor in the numerator and denominator, right? This is divided by 2, you get a 1, divided by 2, you get a 3. So our final answer will be 3 plus or minus radical 3 over 3. And that's what our x's are equal to. Simplified. Okay, so I want you to practice this one, as you can see in the next problem here. I'll give you a few minutes. There's more on your own for the homework. I'm going to subtract 6 to both sides. X squared minus 4x minus 6 is equal to 0. Now I know that a is equal to 1, b is equal to -4, and c is equal to -6. So I plug these into the quadratic formula. I have -b plus or minus the square root of b squared minus 4ac. All of this is over 2a. So far, so good? Okay, so this is equal to +4 plus or minus the square root of positive 16 plus 24 over 2. So this should be 40, right? So 4 plus or minus radical 40 over 2. And radical 40 is what? 4 times 10. So that's 4 plus or minus 2 radical 10 over 2. So how many of you got this far? Got this correct? If you got up to this point, you're almost there. Okay? So look carefully and see what you got different and figure out why. Was it a little careless mistake there or what? Okay. All right, so as you can see in the numerator, you have a common factor of a 2. So I'm going to factor the 2 out, and I get 2 plus or minus radical 10 over 2. And you see the 2's, right? This is 2 times, right? So these are factors. These cancel out. So your final answer is x is equal to 2 plus or minus radical 10. Any questions? Okay, so if you got this correct, you did a great job. Otherwise, just be careful of like these. Make sure you compute under the radical correctly. That's probably where some people made mistakes, especially if you didn't use parentheses around negatives. All right, we have a few more. Now this time, our solutions are going to be complex. And we'll talk about that more in depth. So as you can see here, we have our a. So our problem is x squared minus 2x plus 2 equals 0. So a is equal to 1, b is equal to negative 2, c is equal to positive 2. So let's plug these into the quadratic formula. You get negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. So now we have 2 plus or minus, and then under the radical we have 4 minus 8 over 2. What is 4 minus 8? That is negative 4. So 2 plus or minus the radical of negative is going to be imaginary, right? So remember this, we talked about last week, square root of negative 4 is equal to the square root of 4 times the square root of negative 1, right, which is I, right? The square root of negative 1 is our I, so this is equal to 2I. Okay, it's a quick refresher there. So this is 2 plus or minus 2I over 2. And as you can see, there's a common factor of a 2, right? So in this one, you can just kind of see it this way, right? You can just do 2 over 2 and 2 over 2 here. So your final answer will look like 1 plus or minus I. Okay, so I know that was a little quick, but I don't think it was difficult. I want you to try the next one and see how you get a complex answer here. This is already set equal to 0, so we can just start off, right? Let me use this color today. I got a is equal to 1, b is equal to negative 4, c is equal to 6. So we plug in these numbers into the quadratic formula. We get negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so in the numerator we have positive 4 plus or minus the square root of 16 minus 24 over 2. And as you can see, 16 minus 24, that's negative 8. So 4 plus or minus the square root of negative 8 over 2. So we need to simplify square root of negative 8. So hopefully you got 4 plus or minus This is 4 times 2, right? So square root of 4 is 2, and your I root 2 over 2. Did everyone get that far? As you can see, there's a common factor of a 2. So if I factor that out, I get 2 plus I root 2 over 2. And lastly, the 2 cancels out. So you have two solutions. 2 plus or minus, I forgot the minus sign there, I root 2 as your final answer. Oh, yeah, there you go. Any questions? Okay. The 2i confuses you? So radical negative 8 is equal to radical 4 times radical 2 times radical negative 1. Right? This is 2 and this is I. So you get 2i radical 2. Okay? And that's where we got 2i root 2. Then the next step was to factor this common factor of 2 out. That's why we got 2 plus or minus I root 2. Okay?